Assignment 8. We need to do a little bit of a review and discuss one thing before we can move on with our quadratics. So we need to review simplifying radicals. And we also need to talk about imaginary numbers. We're not going to do very much with it this year just because of time's sake, but we do need to introduce it and let you know what it is and one thing that it's used for. Okay, so we're only simplifying square roots. Square roots mean that the number inside the radicand right here is a 2. And that number tells you how many things you need to multiply to come out. So, for example, if it's square root of 4, that means what number do you multiply by itself 2 times to get 4? So square root of 4 equals 2 because 2 times 2 equals 4. Square root of 25. So if there's no index, this is called an index. If there's not an index, it's automatically a 2. That means what number do I multiply by itself 2 times that equals 25? And that would be 5 times 5. So then that number comes out of the radical. They're just asking, what is the number that I multiply 2 times? So there's a couple ways to simplify these ones that don't come out to be integers. There is no integer that I can multiply by itself to get 40. So all I can do is simplify it. And there's a couple ways to do it. You might have done a factor tree. I do something called the birthday cake. I just think that it helps me stay a little more organized. Visually, I think it's a little bit cleaner. It looks like division because it is division. So you have to start down low, okay? You can't start at the top of your paper because we're going to build up like we're building a birthday cake. So we start here with 40. And we're going to divide by something that goes into 40. So here is the only catch, is it must be a prime number. So I could not divide by 10 because 10 can be broken down into smaller factors of 2 and 5. I can't divide by 4 because 4 can be broken down into smaller factors of 2 times 2. If you just always pick the smallest number that goes into it, you should be okay. So what's the smallest number that goes into 40? 2. So see how it looks like a division problem? Because it is. 40 divided by 2 is 20. So I put 20 up there. And then we do it again. So we build another division. What's the smallest number that 20 is divisible by? 2. And what's 20 divided by 2? 10. And then do it again. 10 divided by smallest number goes into 10 is 2. 10 divided by 2 is 5. And then one last time, what's 5 divisible by? 5 is divisible by 5. 5 divided by 5 is 1. So you know that you're done when you get a 1 on top and it kind of looks like the birthday candle. So see how this looks like kind of a stacked, like layered cake right here. We have a 1 on the top. That's a candle. That's how we know that we are done. So remember I said before, because it's a square root, that means it takes 2 of something, right? What number do we multiply 2 times? And then that number is no longer in the radical. So when we do this birthday cake, we're going to look for pairs of numbers, and then that number can come out of the radical. So I can circle right here a pair of 2s. That means that 2, that number, can come out in front of the radical. The 5 does not have a pair. The 2 does not have a pair. So those numbers cannot come out. They are stuck inside the radical. I only have 1 of them, and I need 2 to get out of a radical. So if they can't come out of the radical, they are stuck inside. The 5 and the 2 have to stay inside, so we put them back in. And when we put them back in, we multiply them. 5 times 2 is 10. So let's try another one. 108. So the smallest number that 108 is divisible by is 2. 108 divided by 2 is 54. The smallest number 54 is divisible by, it's even, so it's divisible by 2. 54 divided by 2 is 27. 27 is odd, so it's not divisible by 2, but it is divisible by 3. 27 divided by 3 is 9. The smallest number that 9 is divisible by is 3. 9 divided by 3 is 3. And one last time, 3 is divisible by 3. So there we go with a 1 on top. Draw my little flame. That's the candle on top of my cake. So I know that I am done. So now I'm going to go through and look for my pairs. Here I have a pair of 2s. So I'm going to be able to bring out a 2 out of the radical. Here I have, it doesn't matter which 3s you use. Here I have a pair of 3s. So I'm also going to be able to bring a 3 out. And when I bring them out, I'm going to multiply. And then this 3 doesn't have a pair, so it has to stay inside the radical. So then if I multiply those 2 in the front, 2 times 3 is 6, radical 3. So probably haven't done the birthday cake method before, but you have done simplifying radicals before. If you have a different way that you like, go for it. If you want to keep doing the factor tree, you can keep doing the factor tree. So we need to introduce you to something new now. And I wish that we could spend more time on it, but this year, it's called an imaginary number. So the number, let's get a good color. Square root of -1. Your whole life, math teachers have told you that you cannot take the square root of a negative number, right? You get to a square root of negative something and we quit and say, it doesn't work. And we're going to kind of change that up on you. So the square root of -1 is called the imaginary number I. I for imaginary. And anytime we have a negative problem, we're going to take the -1 or just the negative sign. So we're going to replace the negative with an I, because then we can go on and continue working with the problem. So anytime you see a negative inside a radical, like here and here, we're going to replace it with an I. The I is not in a square root. Notice I didn't put a square root around it, just an I. That takes care of the negative, and then I can simplify the rest of the problem the way we did these last two. So instead of that negative, I'm going to write that as an I. And then I can go on and simplify the square root of 80. So the negative we write as an I, and then we can deal with the 80 like we did up above. For this one, the negative inside a radical, not if it's in front, but inside a radical, I'm going to replace with an I, and then I can go on and simplify the rest of the radical as we did before. So here would be a great place actually for you to stop and practice simplifying those two radicals. And then you can continue on with the video and see how you did. So if you want to pause, do it now. Okay, so 80. Put it in a division. The smallest number that goes into 80 is 2. That's 40. The smallest number that goes into 40 is 2. That's 20. The smallest number that goes into 20 is 2. That's 10. The smallest number that goes into 10 is 2. That's 5. The smallest number 5 is divisible by. Nothing else goes into 5 except 5. And there's my 1 on top. Okay, so looking for pairs. Here's a pair of 2s, which means I can bring a single 2 out in front of the radical. Here's another pair of 2s, so I can bring another 2 out in front of the radical. Remember, it takes 2 of them to come out of the radical because it's a square root. And then the 5, there's not a pair, so the 5 is going to have to stay inside the square root. And just for notation, that I always goes right in front of the radical, right here. So don't put it in front of here. Don't put it at the end. Really don't put it at the end. It always goes right in front of the radical, right there. So my last step is I'm just going to simplify this. 2 times 2 is 4. Then my I, square root 5. So let's do the same with the last one. 175. The smallest number that goes into 175, it's odd. So 2 doesn't go in. You could try 3. I know it ends in a 5 though, so I'm going to use 5. 175 divided by 5 is 35. It ends in a 5 again, so the smallest number that goes into it is 5. 35 divided by 5 is 7. And now the only thing that goes into 7 is 7. 7 divided by 7 is 1. That's my candle. So I have a pair of 5s. That means that I can bring the 5 out in front of the radical. That I stays right in front of the radical. Nothing goes in between them. And then the 7 doesn't have a pair, so there's not 2 of them. That means it can't come out of the radical. It has to stay inside. And this one actually doesn't have anything to simplify. There's nothing to multiply here. There's only one number inside there. So there's nothing further to simplify.